Hey guys, I wanted to make you a quick video because I had some questions about this week's e-learning, which is located right down here at the bottom. I had some questions on, can you help me out with writing the chemical equation for number 4? Also another question about writing the chemical equation for number 7. And I can help you with that right now. Well, not right now. I'm going to come back to this in a minute. But I want to let you know I'm also going to include like the answer for each problem. So I'll probably write those over here so that you guys can do the work and then check your answer. So you know right away if you did it right or not. So I'm going to erase this stuff. I also had a couple questions about last week's e-learning. So I included last week's e-learning, and I think a couple of you are just missing a couple like key points. And once you get these key points, I think it'll be a lot easier for you to do these problems. So if you look, I'm going to do number 3 and number 5 right now because I had specific questions about those two problems. Now, all of these problems, if you look up here, it says mixed stoichiometry problems. So all of these problems, they're kind of cool because they follow the same basic pattern. So it goes from your given, like the number you are given, and you always convert that to moles. And then you can use your mole ratio. And then you convert to whatever unit you are trying to find. So when you're doing these problems, the given quantity, 2 moles, when you're doing that, you always use your mole map. When you're doing a mole ratio, that's when you use the balanced chemical equation, like those coefficients that we talked about. And when you're doing your field goal, it is always the given chemical on the bottom, and the chemical you're trying to find always goes on top. And then when you're converting to what you need to find, again you use your mole map. So if we look at problem number 3, it says how many grams of KCl. I'm going to go ahead and get this stuff out of the way because that's what I'm trying to find. So I'm going to double underline that. It says how many grams of KCl are produced in problem 2. So I have to look back up here at problem 2 and say, oh, there's my given number. So that's my single underline. And that's also where I'm going to start this problem. So I'm going to write 5.0 grams of KClO3. Now, I've been watching some of your work, and some of you are not including units and numbers. If you're not including like your unit and what you're in, it's really hard to figure out like what unit you're going to or where you're at in the problem. So if you're not in a habit of writing like grams of KCl in there, please work on that. Makes life a lot easier in the long run. Okay, so we're going to go from grams, and that is our given. And we are going to then convert to moles, and it says to use the mole map. So we're going to go over here and take a look at our mole map. And we are in grams, and we're converting to moles. So we're going to go this way, and right here is our total amount. It says 1 mole over the molar mass. So if I go back over here, I'm going to write 1 mole of KClO3. See how I included that KClO3 on there? That makes it a lot easier in a minute because I know exactly what unit I'm in. Now on the bottom, I need the molar mass of KClO3. So I need the molar mass of that, and I get the molar mass from looking at the periodic table. So I need to add up KClO3 3. Now, this is actually my third time making this video, so I already know what it is, but I'll run through it with you guys. So I'm going to add up potassium, which is 39.1, plus Cl, which is 35.45, plus 16 times 3 oxygens, which gives me 122.55. Okay, so that's the value that I put here, 122.55. Okay, so units that cancel out. Let's see. Grams of KClO3 cancel. Now, if I stop my problem right now, because I've taken the time to write the units, I know that I'm in moles of KClO3. Like if I just did my math and took 5 divided by 122.50 or 55, my answer would be moles of KClO3. But I don't want to stop here. I want to go ahead and use my mole ratio. So my given chemical is moles of KClO3, and what I'm trying to find is moles of KCl. So I look up here. I have to do some, no, I don't have to erase. Okay, good. Okay, so it's 2 and 2. Again, this is the only step that I use those coefficients. So it's 2 and 2. Units that cancel out are moles of KClO3. Cancel, cancel. So now I can convert to grams. So I look over here at my mole map, and now I need to use this conversion because I'm going back to gram city. So molar mass over 1 mole. So 1 mole of KCl. I'm going to go down here and add it up. So KCl, so 39.1 plus 35.4, 39.10 plus 30, there you go, 35.45 is 74.55. So that's what goes here, 74.55 grams of KCl. Now I'm going to cancel out my units, cancel, cancel, and I am in grams of KCl. So grams of KCl and grams of KCl is what I'm trying to find, and I know that because it's listed right there. So now I'm going to do math. I'm going to take 5.0 times 2 times 74.55 is, is, there we go, is 74.5 divided by everything multiplied together on the bottom, so that is 122.55 times 2, which is 245.1. Okay, so that equals, now I'm going to divide 745.5 divided by 245.1, and that gives me 3.0416 blah. Okay, so we go back and we look at our very first number here, and that is 5.0. So we can only have 2 significant figures, so my answer is 3.0 grams of KCl. So that was the work on that problem. Let's take a look at number 5 really quick. It says how many molecules of water are produced if 2 grams of sodium sulfate are produced in the above reaction. So this problem's a little bit different because it says molecules of water. So the pattern for this one is slightly different. It's grams, 2 moles, because we're starting in grams right there, 2 moles. Then we can use our mole ratio from our balanced chemical equation and then convert to molecules. So really this is the only different part in this problem. So we're going to start with our number given. So 2.0 grams of Na2SO4, which is sodium sulfate. Then we're going to convert to moles. So we have, if we look at our mole map, it is 1 mole of Na2SO4. And then we're going to need the molar mass of Na2SO4. So we're going to go down here and add it up. So we're trying to find Na2SO4. So I'm grabbing my calculator, 22.99 times 2 plus sulfur is 32.06 plus 16 times 4. Okay, so 142.04. So that's our number that goes here. 142.04. Okay, let's see our units that cancel out here and here. Right now we're in moles of Na2SO4 because that did not cancel out, but we are in moles, so we can go ahead and do our mole ratio. So we're looking for molecules of water. Our coefficient in front of water is a 1. Our coefficient in front of Na2SO4 is also a 1. So I have 1 mole of H2O for every 1 mole of Na2SO4. So units that cancel out here are here and here. And now I need to go to molecules. Right now I'm in moles, but I need to go to molecules. In order to do that, I need to look at my mole map. So I'm in mole city, but I need to go to particle city because particles are things like atoms, molecules, so they live down in that part right there. So in order to go from moles to molecules, I need to use this conversion factor right here, 6.02 times 10 to the 23rd particles over 1 mole. So that's what I'm going to put right here. So 6.02 times 10 to the 23rd molecules of water, H2O, there we go, over 1 mole of H2O. So units that cancel out are moles of H2O, and I'm in molecules of H2O, so it's time to grab our calculator. Now, I'm going to pause for 2 seconds, literally 2 seconds, because you need your calculator, because some of you have your work right, and then you're entering it in your calculator incorrectly. So grab your calculator. Okay, so we're going to go 2.0 times 6.02 EE button 23 equals. Okay, that gives us 1.206 times 10 to the 24th divided by everything on the bottom, which is 142. 142.04. Okay, divided by 142 equals, okay. So for this one, let me just refresh my math really quick. 2.0 times 6.02 E23 divided by 142.04 gives me this. Okay, so my answer that I get on my calculator is 8.47648 times 10 to the 21st. But I cannot have that many significant figures. I can only have 2 because my starting number only had 2 significant figures. 2 and 0 are both significant. So my answer is, I have to round, my answer is 8.5 times 10 to the 21st molecules of water. So there's my answer. Now, I hope that helped you on last week. Let's look at this week really quickly. I already gave you the balanced chemical equation for number 1 in the last video. And if you look down, like for 1, 2, and 3, you already have the balanced chemical equation. But if we look at number 4, you have to write another one. And it says calcium reacts with water. Okay, so I'm going to write the skeleton equation. I'm not going to balance it for you, but I'm going to help you write the skeleton equation. So it says calcium, so Ca. So Ca reacts with water. There's a trick right there. I don't know if you guys remember, but we can write water as HOH here. Reacts with water, so the Ca is the positive part and the H is the positive part, so Ca is actually going to go with OH. So if I think about it, I have Ca that's 2 plus and OH that's 1 negative. So if I cross those charges, I get CaOH 2. And then who's left alone? Hydrogen is left alone. And when hydrogen is by itself, it is a diatomic, so it's H2. So there's your chemical equation for that one. It is, again, not balanced. It's just a skeleton equation. You need to balance that so that you can get the appropriate mole ratios to go with your problem when you're trying to do this 10 grams of water. So when you're doing that, please balance the equation. That is just a skeleton equation, but it will help you know if your answer is right. Now, if you go down here to number 7, it says sodium hydroxide and sulfuric acid neutralize each other in a double replacement reaction. So sodium hydroxide is sodium and hydroxide, O hydroxide. And if we cross those, we get NaOH. I know that sulfuric acid is made from sulfate, so it is going to be H2SO4. And a double replacement, I know that H is going to go with OH, so I get some water. I'm going to make that HOH so it's easier for you guys to balance. So we have HOH, and we have Na with sulfate. So we have Na2SO4. Okay, again, that is just a skeleton equation, but you guys need to balance it, and it's actually really easy to balance. And then you can have the right mole ratios. And as promised, I told you guys I would give you the answers. So for number 2, the answer after you do it is 0.308. The answer for number 3 is 20.7. Number 4 is 11.1. This one is 0.550. This one is 20.5, and this one is 8.7. Now, good thing also about these problems, all of the ones on this page are all mass to mass. So your pattern is grams to moles. Use your mole ratio, convert back to grams. So remember, this step, mole map. This step, balanced chemical equation. And then this step again is mole map. Okay, so I hope this helps. If you don't know how to do one, or you would like me to check your work because you're not getting the right answer or the answer that I came up with, let me know by email or remind, and I will take a look at your work. Hope this helps. Hope you're having a great day. Miss you guys bunches. Talk to you later.